Hi, I'm Mick Grove from MongoDB, and I want to talk to you about a program that I wrote and that we're planning to open source very shortly called Kingfisher. This tutorial is going to show you how Kingfisher, our new open source secret scanning tool, can strengthen your existing workflows by reducing noise and help you focus on real threats. So first off, what is Kingfisher? After more than, it's hard to believe, 20 years in security engineering, I was really frustrated with the limitations of existing secret scanning tools. I found they really generated just too many false positives, they were too slow, and often they didn't have any way to validate the secrets at all. In summer 2024, I actually set out to build a better solution, one that not only detected the exposed secrets, but also was able to verify their validity and did so extremely quickly. That solution actually became Kingfisher. So Kingfisher is an open source tool, as I mentioned, that helps organizations and developers detect and manage exposed secrets across Git repositories, their history. It can scan files and directories and more. So unlike a lot of other secret scanning tools or basic secret scanning tools, Kingfisher can not only find them, but validate whether or not a discovered secret is actually a true positive by checking with a third-party API provider, which reduces false positives and helps security teams like ours at MongoDB focus on real risks instead of chasing down secrets that have already been rotated or are not actually valid. So one of the key features of Kingfisher is that it combines high-performance scanning and accurate detection to detect exposed secrets at scale. I wrote this tool in Rust for speed and reliability, and it leverages the Hyperscan regular expression engine for high-speed regex matching. And it actually uses the tree sitter library for accurate source code parsing. And right now, Kingfisher supports over 20 different programming languages. What that means is not only can Kingfisher very quickly find secret patterns, but it actually is able to parse source code to not find things that could not possibly be valid syntax or evidence of a secret. Beyond detection, Kingfisher focuses on actual actionable results. The scanning engine is multi-threaded. There are 750 custom rules written right now for detecting secrets and validating them. As I mentioned, it parses source code, and there are entropy checks so that we can flag only the high confidence secrets. All of this is actually configurable in a YAML format and can be updated very easily without understanding or writing any Rust source code. As I mentioned, we go a step further with our dynamic validation by automatically checking if a detected secret is active by hitting the cloud provider APIs or testing database. With flexible YAML-based rules and seamless CI/CD integration, Kingfisher fits really easily into our workflows, and we think it'll fit really easily into your existing workflows to strengthen your overall secret management strategy. So there are a lot of different ways that you can actually use Kingfisher. You can integrate it into your existing development workflows, your CI/CD pipelines. You can use it as a pre-commit hook or just as a part of your regular scanning. At MongoDB, we're using Kingfisher across our development lifecycle, from scanning code before it's committed to automatically validating credentials during our CI/CD testing, and to analyze historical repos for past exposures. It's something that's been really valuable to us because it's helped us catch real risks early and take quick action when needed. So as part of our commitment to security, we're making Kingfisher open source under Apache 2 license so that the entire developer community can better protect their sensitive data. Whether you're a developer trying to catch issues before they ship or a security engineer looking to reduce alert fatigue, Kingfisher is actually built to help you focus on what matters, real risks. It's extremely fast, faster than any other existing source code analysis tool available as open source. It's flexible, and it's designed to fit seamlessly into your existing workflows. Now let's step into a couple demos to show you what this program can actually do. So I've got my terminal here, and Kingfisher is intended to have a very simple syntax. So you don't need to tell it a lot about what you're scanning. So if you're going to scan just files and directories, or if you're going to scan Git repos, it doesn't really matter. Kingfisher will discover, if there is a Git repo, Kingfisher will discover it and scan it. Because Kingfisher is so fast, you can actually scan very large repos. So to start off with, I'm going to scan the GitLab repo, which I've actually cloned locally on my system. So I don't have to tell Kingfisher that this is a Git repo or just a collection of files. It will discover it and scan it in the most appropriate manner. One option I'm going to add is to specify that I only want Kingfisher to report the valid secrets, that are secrets that it was able to reach out to the API provider and confirm actually are tokens that exist. So Kingfisher by default is going to load. It's right now 746 rules. Then what it does is it enumerates the entire Git commit history for the GitLab repo, which is extensive. And it will take about 2 minutes overall to perform this scan. Once it discovers, as it's scanning files right now and looking at the commit history, it's applying the Hyperscan regular expression engine, it's parsing source code, and it's collecting potential matches. Once it finishes the scanning, it will actually go into a validation stage. So the validation happens after the scanning. You can optionally turn off validation. That's one of the supported command line arguments, but we're going to let it run. Okay, as we can see, it has completed scanning. One of the things that Kingfisher does is it automatically deduplicates results, so that this secret it actually found, because I've scanned this in other ways, I know it found this secret in 6 different locations. By default, that isn't shown to the security developer, the security engineer that receives this report, because the secret only needs to be fixed in one location. And the way you fix a leaked secret is to rotate it. We can see it finished. It was able to scan over 80 gigs of data in 2 minutes. It found 1,300 findings potentially, but was only able to validate that there is actually just one finding here. Now, what's interesting, if you look in our Git repo, we have a comparison section where we compare other scanning tools that exist to Kingfisher. And I think it's worth pointing out that Kingfisher finishes in 2 minutes. When compared with TruffleHog, it's over 5 minutes on this same system. GitLeaks is a little slower as well, with nearly 6 minutes. But what's really interesting to me is that Kingfisher makes 17 network requests. That's it. It only makes 17 network requests in this repo of 80 gigs to determine that there is one valid API key. TruffleHog itself makes over 15,000 network requests and takes 3 times as long. So this is one of the key improvements, is less noise on your network and a much faster scanning tool. If you wanted to see every result in every location that it exists, including the commit history, you could simply run it with the no dedupe flag, which will ensure that it will report every finding individually, regardless of where it's stored at. And this is an option for teams. Now, one of the other things I like to show off is that not only can Kingfisher scan a repo that exists on your system, but it can actually reach out to GitHub. So if we want to take any repo that exists on GitHub, you simply have to pass the Git URL parameter, and then you provide the repo. And that's it. If it's a public repo, it will be able to reach it by cloning it locally and scanning it. If it requires credentials, you will have to use, and this is in the README, you will have to set an environment variable with your GitHub token. And then that would allow it to be used. So here I'm going to do kind of the same scan as before. It'll be much faster. I'm just specifying this repo, which has a lot of histories, a lot of keys stored in the commit history that have been removed. So one of the key features here is that Kingfisher is able to look at the Git commit history. So if a secret has been committed and a developer discovered it, goes in and deletes the file and recommits it to GitHub, that still exists in history. So Kingfisher will go look for those things. So let's kick it off again with the only valid flag. So right now that was extremely fast. And we can see it found some AWS secret access keys. These happen to belong to, they are canary tokens. So these do not represent actual security vulnerabilities. These are simply for security engineers to detect breaches. So these will not actually grant you access to anything. However, what's nice about this response is not only do I get the finding, which is the secret key, I actually have a report that it's an active credential. I receive the AKID, the Amazon key ID, and I also receive the account ARN and the AWS account number. This is extremely valuable for security engineers because a report of a bunch of leaked keys doesn't really help me track them down. I need to know what account they belong to. A lot of organizations have many AWS accounts, and this feature allows you to find that. The other thing that's useful is when a secret is found in a Git repo, Kingfisher will actually report the repo, the exact commit, and the link to the GitHub repo. So you can actually follow this in GitHub, and it will take you to the exact line that it was found on. And finally, there's a git command. Because this was cloned locally, you can actually run this git command, and it will show you this file in the commit history. So that saves a lot of time if you just want to validate it. We can do that here, and we can see down here that this is the contents of that file. One of the things I want to show off is that Kingfisher can actually validate secrets really quickly. So there is a repo that exists in GitHub where somebody committed over 10,000 GCP keys. And so I cloned that repo locally. And fortunately, none of these keys are actually valid any longer. So I'm going to demonstrate that scanning. And notice I didn't pass the only valid parameter. If I had passed the only valid parameter, it would actually not report anything because none of these are valid. And we can see here with Kingfisher, it has very quickly completed its scanning, and now it's spending its time in the validating matches. So it's actually reaching out to the GCP API, and it's checking whether these 5,480 keys that it has discovered are actually usable or not. And we can see here that we have returned every single key that was discovered. So everything from private keys to GCP API tokens. Notice it actually calls out the private keys separately from the GCP API token. That's because there are private keys in the actual token. We can see that it actually found 16,000 findings. That's because it's identifying different pieces through the GCP key, and it attempted to validate them all, and there were no successful validations. But what's really interesting here is it did that in 79 seconds. It was extremely fast to validate that many keys. Lastly, I want to show off the rules. So there's a very flexible rule engine. It allows writing custom rules in a YAML format, and that includes writing the validation section. So you can actually write in the YAML file how to validate a particular secret. So I'm going to show you how you can see what secret detections already exist by simply running Kingfisher rules. If we run this, you can actually see there's two commands. We can check to make sure if you've added a rule, whether or not it actually has a problem. And then you can actually just simply list all the rules that exist. And if we were to pipe this to the file, you would actually be able to see the full regular expression that is used here. But we have a number of rules, and there are over, I believe, 750 at this time for a wide variety of APIs. What we're looking to do is continuing to add more of these rules. We've targeted some of the most popular services that we are aware of and have added those to Kingfisher. So one of the things we love from the community is adding even more rules. And one of the last things that I wanted to share with you, and one of the reasons that I really cared about building a tool like Kingfisher, is because of its high performance, we are actually able to scan the entirety of all of our internal developer repos from beginning to end, which means full commit history, in under 30 minutes. Using other similar open source tools, that work would take 4 to 6 hours. It did take 4 to 6 hours. Because Kingfisher has such high performance, we're now able to scan those repos on a regular basis and catch any missed secrets that have evaded our previous detections or weren't part of an existing rule. So thanks for taking time to check out Kingfisher with me. I think it's a really valuable tool in your tool set. And one of the reasons I built it was so that MongoDB and other companies like MongoDB can solve their secret discovery problem. Read the announcement blog post, check out the repo, try it out in your environment, and let us know what you think. Please reach out to me on LinkedIn. My name is Mick Grove. I'm a staff security engineer at MongoDB, and we'd love to have your feedback or just simply add a comment to this video and let us know what you think. Thanks.